doing? Welcome to Go Score, the fastest growing edtech in GCC, and our main aim is to provide the quality education for all. And today I am here with the revision session, as you might be already knowing, right? The session will be so interactive and fun. For that, I want your participation, and not just the participation, an active participation. Are you guys ready for that? Alright, I'm not getting any comments in the comment box. It's almost like dead. Just can you post something on the comment box so that I will be so energetic and we can go ahead with the revisions. Are you guys ready actually? Hello, are you guys there? Yes, right? Alright, we'll go ahead with the revision session. But before getting into the revision, I'm just taking a moment to celebrate our special occasion. What is that special occasion, guys? Before that, I'm going to change the slide, okay? Alright, so what's our special occasion today? As you might be already knowing, it's our Children's Day, right? So happy Children's Day, guys. So how are you guys doing on the Children's Day? Was it good? Have you celebrated everything? And I know it's not only the children, so many parents also might be like looking into the revision sessions, right? Joining with your children. Of course, age doesn't matter, right? Age is not just a number, right? So coming into the Children's Day, everyone in one way or the other way, everyone are children, right? So on the Children's Day, and can you see a happy face? You might have not seen, but there is a happy face sitting over there behind the camera. All right, so sitting back in my home, that's my mom. So my mom will be watching this live. I know she might be there, and with a happy tears, she might be the most proudest woman in the world looking after me, because you know, the mother's feeling, it's really good. And on this Children's Day, I really appreciate my mom for everything, and thank you so much, Mom, if you're watching right over there. And also, the children, if you're watching this with your parents, just take a moment and just give a tight hug to your parents and tell them how much you love them and how much you appreciate their presence, because these are the small moments that we have to enjoy in our life. It's not only about the studies, right? So just enjoy every moment. Okay, we know that we are getting into the exams, a lot of tension, stress. I know that, but just take a moment to thank your parents. Okay, they are there to support you, to guide you, to get you into your dreams and everything, right? So just take a moment to thank them, as I did to my parents, right? They might be so happy to see me right over here. All right, so not wasting any of my time right over here, because we are getting into the revision section, right? So as you might have already informed, the revision session is about the chapter Chemical Kinetics. That's your third chapter from our syllabus, okay? So before getting into the chapter, I'm going to let you know the pattern of the question paper so that you will get an idea how you're going to prepare for the exam, right? And within 3 months, you're going to write a board exam, right? So you should know what is the pattern for the question paper first of all. So we'll get into the pattern. Here we go. Actually, it's really simple. And the chemistry, the paper will be out of 70 marks, okay, which will be having 5 sessions, as you can see right over here. And the first session is carrying 1 mark. That's nothing but your MCQ part. And you will be having 16 MCQs. Okay, let me change the color of the pen. Okay, I prefer yellow. Now, there will be 16 MCQ, as you can see, which will be carrying 16 marks. And out of which 4 will be your assertion, reason type of questions. Okay, coming into the second session, that's your very short answer type of question. Very short answer type of question. Okay, which will be carrying 2 marks for each. And since we have 5 questions, the total marks will be 10. And coming into the 3 mark question, which will be having 7 questions inside that and carries a total of 21 marks. Now you have gone with a 4 mark question. That's nothing but your case-based question, and you will be having 2 case-based questions, and which will carry a total of 8 marks. And finally, you have 3 long answer type of question, which carries 5 marks. Okay, so that will be giving you a total of 15. So altogether, a 70 mark of question paper. So are you guys prepared for this pattern of exam? Definitely you guys will be prepared with our well-prepared revision sessions, isn't it? Okay, I'm able to see many comments over there. Thank you so much. I am your mom's friend. All right, so everyone is joining right over there. I'm really happy to see those comments over there. All right, so getting into the next concept, that is nothing but the weightage of the chapters. Okay, so we know that we are dealing with the chemistry, which will be contain how many chapters. So without letting me know how many chapters are there in the chemistry, I'm not going to move forward. Just let me know how many chapters are there in the syllabus. All right, go ahead, tell me. Where is that? Just tell me how many chapters do we have in the syllabus? Not getting any comments. Are you guys still there? All right, so I'll continue without wasting the time. All right, we'll be having 10 chapters in the syllabus. Okay, we'll have 10 chapters. I hope you know what are the chapters that we have, correct? So this is the chapters that we have, and we know that the chemistry will be divided into 3 types. That is your physical chemistry, inorganic chemistry, and finally the king of chemistry, the organic, right? So coming into the first chapter of chemistry, that's your solution. The weightage of this chapter is just 7 marks, okay? All right, so coming into the second chapter, that is your electrochemistry, okay? And this is one of the most important chapter that you can find in the syllabus, because this is the chapter with more weightage, that is of 9 marks, guys, 9 marks. So you have to pay a little more attention to this chapter so you can score all the 9 marks without losing any marks. Okay, getting into the third one, that is chemical kinetics. That's what we are going to discuss it today, okay, which will be carrying a total of 7 marks. Now, D and F and the coordination, they are really simple chapters, right? If you know the concepts, you can score well in the chapter. Well, both of them carry 7 marks, okay? The marks allocated for both the chapters will be 7, okay? Now, moving into the next one. Okay, comes with our organic portions. I really love the organics. What about you? Which portion do you like the most? The organic, inorganic, or the physical? Alright, so we'll be having haloalkanes and haloarenes. That is the first chapter in your organic, which will be carrying a total of 6 marks. And coming into the second organic chapter, that's the alcohols, phenols, and ethers. That again carries only a 6 marks, okay? So in these type of chapters, you only have to concentrate on the name reactions and the give reason type of questions, okay? I have more tricks and tips for this chapters. For that, you have to wait for another revision session, because today we are going to deal with the kinetics, okay? So the next chapter is aldehyde, ketones, and carboxylic acid. Again, the second most important chapter in the syllabus, because it carries 8 marks, okay? So the electrochemistry and the aldehyde are the 2 chapters with a more weightage, okay? So concentrate on these chapters, okay? We'll go ahead, right? Now coming into their minds, that is the smallest chapter that you can ever find, right? And the simplest chapter as well. If you read that, you might have already learned all the reactions in the amines in the previous chapter. So if you just brush up, definitely you can get 6 out of 6 from the chapter amines, okay? Now we have finally, we have the biomolecules, which will be carrying the 7 marks. If you are good at biology, this chapter is nothing, guys. Easy peasy lemon squeezy chapter, okay? So if you know about the biology, you don't have to worry about the biomolecules. And altogether, you will get a 70 marks of paper. Okay, so this is the weightage of this chapter. Now you know exactly which chapter that you have to concentrate on to get more score. To score more, just focus on these weightage and start preparing, because the exams are on the doorstep and the pre-boards are coming, of course. So just start preparing. Okay, you might have already started preparing, right? So if you are not, today is the right time, start it. Okay, so nothing to worry about, we'll start it together. Okay, I can see a lot of comments over there, and thank you so much for the big support. All right, we'll go. Okay, so here we go with the chapter Chemical Kinetics. And this chapter, we are going to discuss the most important question or the previous year question that they are repeatedly asking. Okay, they are repeatedly asking these kind of questions. That's exactly why I have added this question in the revision session. So if you feel like bored during the class, not now, so in between the class, you are like very free to go and take a break and come back. Okay, by the way, just pause the video and again come back. Okay, so you don't have to miss any sessions. Okay, so just take a water break, drink water, staying hydrated is really important when you come into the studies. Okay, stay hydrated, stay healthy, and stay tuned with me to get more questions. Okay, we'll go. Alright, here we go with the first question. Define the following terms. Okay, so you have the rate of the reaction, order of the reaction, rate constant, and the activation energy. When you look into these kind of topics, definitely we know that these are plays an important role in the papers, because when I look into the previous year question paper, there is one question related to any of this topic. So make sure that you learn this topic today itself, now itself. Okay, there is no confusion in that. You're going to learn along with me. Okay, so what you're going to do? Take a book. What are you waiting for? Just take a book, take your pen, write down the question along with the answer. So if you just before the exam, if you turn the pages, oh, this is the concept, you will get an idea about that. So make sure to write down the question along with the answers. Okay, so getting into the answer, the first one, rate of the reaction. What do you mean by the rate of the reaction? You might have already completed the revision about all the chapters. Now we are getting into the questions, so you might be already knowing the concepts, right? So can you just tell me what do you mean by the rate of the reaction? Of course, rate is nothing but the speed. Okay, rate is indicated by the speed of the reaction. Okay, now let's consider a general reaction. Let's consider general reaction where we have the reactants, which will be converting into the products. SLR, reactants will be converting into the products. Now we know that as the time passes, when the reaction proceeds, what happens to the concentration of the reactants? Definitely, the concentration of the reactants will be decreasing. Concentration of the reactant decreases, and what happens to the concentration of the product? Okay, as the reaction proceeds, as the concentration of reactant decreases, concentration of the product increases, because reactants are converting into the products, right? So definitely the concentration of the product will be keep on increasing during a chemical reaction over the time. So this is nothing but the rate of the reaction. So rate of the reaction can be expressed as change in concentration of the reactants or change in concentration of the products with respect to time indicates your rate of a chemical reaction. How fast the concentration of the reactant can decrease, how fast the concentration of the product can increase during a particular chemical reaction. That gives your rate of a chemical reaction. Okay, now if we write that in mathematical expression, okay, rate will be exactly equal to, we know that the reactants are disappearing, right? If they are disappearing, we can write that in terms of negative. Okay, so in terms of reactants, there is a negative mark right over there, because we know that concentration, there's a change in the concentration change, like it's decreasing, and the rate cannot be a negative value. Okay, so if you take, just imagine that the concentration of reactant is 1. Okay, now it is like changing into, like it's decreasing, right? So now the concentration of the reactant is 0, or let it be taking as 2 are the products. Okay, so let it be 2. Now when we take the difference, it will be exactly -1, right? The difference will be -1. So there will be a negative charge right over there, and if you put the negative over there, the rate will be negative. So we know that the rate cannot be negative, so always put a negative charge over there. Wait a second, let me erase this. Okay. Okay, so if you put a negative charge over there, both the negative charge will get cancelled and we will get a positive quantity. So rate will be negative, D concentration of the reactant divided by dt. Okay, so rate will be expressed in the positive terms. Put a negative if you are expressing the rate of the reaction in terms of the reactants. Okay. Now, coming into the products, how do you write the rate of the product? Rate of the formation of the products, okay? So, since we know that the products are forming, right? Definitely it will be a positive value. The concentration of reactants are keep on increasing, right? So, definitely it will be a positive value. So, you don't have to worry about the negative sign over there. It's already a positive value. So, never ever put the negative in terms of the products. So that will be nothing but D, concentration of the product divided by dt. Why do we write the dt over there? Because we are measuring in terms of the time, right? So change in concentration of the reactants or the products with respect to the time. That's exactly why I wrote dt over there. Okay, so this is how you will be expressing the rate of a chemical reaction. So if they have given with a chemical reaction, you should know how to write the rate of the reaction. Okay, so we'll be having the examples in the upcoming examples, like the questions. So you will get a better idea about that. Okay. Now, coming into the order of the reaction, which is even more simpler than that. Okay, so order of the reaction is nothing but sum of the products of the concentration. Okay, so the concentration, when we write the concentration, we'll be writing some power at the top, right? When we calculate the power, when we take the sum of those powers, we will definitely get the order of the reaction. Suppose I'm going to take a general reaction. Okay, let's take a general reaction where AA plus BB gives CC and the DD. Okay, so this is the chemical reaction that we have in our hand. What does this A and the B indicates? Capital A and the capital B. Definitely those are the reactants. Now, what is the capital C and the capital D indicates? That's your products. Okay, so reactants gives the products. Now, what is the small letter A, small b, small c and the small d indicates in a particular chemical reaction? They are nothing but your stoichiometric coefficients or the number of moles. Okay. Now, if I tell you to write the rate law expression for this, how do you write? How do you write the rate law expression? So, in the rate law expression, you only have to care about the reactants, not the products. So, when we are writing the rate law expression, the rate can be equal to rate constant. Okay, you have to multiply with the rate constant. So, rate constant into concentration of A to the power x. I'll let you know what is this x indicates. Now, the concentration of B to the power y. Okay, so we know that A, B, C and the D, small letters, they are the stoichiometric coefficient. But what is this x and the y indicates over there? X and the y are nothing but they are determined mathematically. They are just the experimental values, but they may or may not be equal to the stoichiometric coefficient. In all the cases, it cannot be equal to the stoichiometric coefficient. It can be equal, but not all the time. So, according to the rate law expression, if you calculate this x and the y together, you can find the order of the reaction. So, what is order of the reaction, guys? Order of the reaction is nothing but x plus y. Okay. So, when you find the sum of the powers of the concentration of the reactants, you will get the order of the reaction. Order of the reaction, which is really important. They will be giving a particular rate equation. They will ask you to find the order of the reaction. Definitely, we will be having the examples in the other questions. Okay. Alright, so that is the order of the reaction. Coming into the rate constant, which is even more important. Okay. Now, let's consider we have the rate equation right in our hand. Let's consider the concentration of A and the concentration of the B as 1. Okay, I'm going to take the concentration of A and the concentration of B as 1. Okay, if I take the concentration of A and the B as 1, how do you rewrite the rate equation? The rate equation becomes equal to K into 1. That's exactly equal to K itself, right? And this K is nothing but your rate constant. So, rate constant can be defined as it is the rate of a chemical reaction when both the reactants or all the reactant, the concentration will be taken as 1. If you take the concentration of reactant as 1, the rate of the reaction can be called as the rate constant. Okay. Now, you might be wondering how do we define it in words, right? So, I have the slide with the answers, so that you can pause the video and take a screenshot and write it down. Okay. Now, coming into the last one, activation energy. Now, what do you think an activation energy is? So, we'll be having a particular chemical reaction, right? So, at what stage the reactant is converted into the product? We'll be having some criteria to get the reactant into the product, right? Simply, can a reactant convert into the products? No, we cannot, right? So, there is a particular amount of energy that is required by this reactants to convert into the products, right? So, just imagine that if you want to run for a marathon, you are running for a marathon, okay? So, you want the energy to run, right? If you doesn't have any energy, if you have 0% energy, Do you think you can complete the marathon? Of course, you can run for some distance, but you cannot complete the marathon. If you want to complete the marathon, you should require some minimum amount of energy to get cross the line, right? In order to cross the line, you should have the energy. Likewise, the reactants must possess some energy to get into the reactant. So, activation energy is nothing but a barrier which must be crossed by the reactant to get into the reactant. So, how do we define the activation energy? It is the amount of energy required by the reactant to convert into the product. Okay. So, these are the 4 terms that you have to remember. Now, getting into the definition of each, we have this many. Alright. So, pause the video. Take a note of all the definition. This is exactly how you should be writing in your paper. Okay. So, I just explain it for your understanding. You don't have to explain that much for the 1 mark. Okay, these are all 1 mark questions. So you will get only 1 mark if you write the rate of the reaction. So don't write an essay for the rate of the reaction. Don't waste your time. Okay, so the answer should be limited just for the 1 mark. You should know how to write according to the marks. Okay, so I'll be having the tricks and the tips, of course, but you have to wait for that. Okay, so this is the first definition, and the second, third, and the fourth. Just get a note of this and let me know. Okay, take a pause and write this down. Meanwhile, I'll look into the comments. Okay, are you guys there? Hello. Hello guys. Are you guys with me? If you're with me, just can you give me some comments? Alright, if you're with me, just fire up the comment box. It's almost like a dead. I have to put a wreath over the comment box now, because almost like that. They're like just move away from the slide, ma'am, so that you can note it down, right? Okay, go ahead, go ahead. Alright, now moving into the next one. Express the rate to the following reaction in terms of formation of the ammonia. So I told you, right, how to write a rate expression for a particular type of reaction. So keeping that in mind, let's solve it together. Okay, so express the rate of the following reaction in terms of the formation of ammonia. So this is a particular reaction given. Now we are going to write the rate expression. Rate is equal to. First of all, we are going to express that in terms of the reactants. Again, you can go ahead with the product afterwards. Okay. So coming into the reactants, don't ever forget to write a minus charge over there, and don't forget to care about the stoichiometric coefficient as well. You have to divide the stoichiometric coefficient, guys. Here we go. So rate expression can be written in terms of the reactant, that is minus. Okay, minus, and the concentration of N2 divided by. So hold on a second, let me write it more neatly. Alright, N2 divided by dt. So dN2 divided by dt. Okay, that can be exactly equal to the formation of the NH3 and also the disappearance of the hydrogen as well. So when you write the disappearance of hydrogen, this stoichiometric coefficient, can you see there's a 3 at the beginning, right? So don't forget to write that as well. So minus 1 divided by 3 d concentration of H2 divided by dt. And that will be exactly equal to the appearance of the NH3 or the ammonia. So again, care about the stoichiometric coefficient, but you don't have to put a negative sign over here. So it is equal to 1 divided by 2 into d concentration of NH3 divided by dt. This is how you will be writing the rate expression for a particular kind of reaction. But remember one thing, what they are asking in the question. They are not asking about the disappearance of N2, neither the disappearance of hydrogen. So they are asking for the appearance of NH3, where you only have to write the rate is equal to 1 divided by 2 d concentration of NH3 divided by d. Okay, so this is the only expression that you have to write over. Okay, because they are only asking for the in terms of ammonia. Got the idea? Now shall we get into the second one? Don't you have any doubts? I'm not finding any doubts in the comment box. Why not? Because you know everything already? Alright, now let's solve it. If the rate of formation of NH3 was found to be that much, 2 into 10 to the power minus 2 mole dm raised to minus 3 minus like second inverse. Okay, what will be the rate of consumption of N2? Can you solve this? If you know the concept, it's very easy. Just go ahead. You can use the same thing. You can use the same thing for the calculation. Okay, that is nothing but they have given with the term this. Okay, they have given this much. All right. Now you have to find this. Okay, we know that both of them are equal to each other, right? Shall I erase this because I don't have enough space to write down? So I'm going to erase this, okay? I hope you have the answers with you guys. All right. So the rate can be expressed as, okay, that is minus d concentration of N2 divided by dt. So rate of the disappearance of nitrogen is exactly equal to the rate of appearance of ammonia. That's nothing but that's exactly equal to 1 divided by 2 the concentration of NH3 divided by dt. Okay, this is how we'll be writing it. Now, coming into the calculation part, you have to find this. For that, we know the value of this. Alright. Now, when we calculate that, it's 1 divided by 2 into, what is the rate of formation of ammonia? It is 2 into 10 to the power minus 2. So 1 by 2 into 2 into 10 to the power minus 2, which we can write it as 1 into 10 to the power minus 2. And don't forget to write the unit mole raised to dm cube. And we have the second. Okay, so this is how you will be writing the answer for this particular question. Is that clear? Do anyone have any doubt on this? Or else we'll move ahead. Okay, so is there any doubt? No, right? So we'll move ahead with the happy faces. Here we go with the next type of question. Okay, if the rate constant of reaction is given 10 into 10 to the power minus 4, then identify the order of the reaction. I told you, right, they will be giving a type of reaction and ask you to find the order. For that, they haven't given the rate expression. So how are you going to find the order of the reaction? Can you just let me know which is the method that you'll be using to find the order of the reaction if they have given the K value? Anyone? Anyone in the live? Can you just let me know? Yes. Let me know how do you find the order of the reaction if they have given with the number with the unit. Alright, so unit really matters, right? Do you know what is the unit of the K for zero order reaction? Which is really, really important, okay? For a zero order reaction. Zero order reaction. Okay, for a zero order reaction, what will be the unit of K? What will be the unit of K for the zero order reaction? Definitely the K will be equal to mole liter inverse second inverse. That's the unit for the K for a zero order reaction. Now coming into the first order reaction. For a first order reaction, you know what? I have a bad handwriting. Do you know the reason? The students that are sitting in my hand, like class, might be knowing why do I have the bad handwriting, because genius will be having always the bad handwriting. That's exactly why I have the bad handwriting. Don't mind that, okay? Alright, so the first order reaction, okay? Because I always tell this in the class, why do I have the bad handwriting? Alright, so the first order reaction. The first order reaction, the unit of K is just the second inverse. It's just the second inverse. Okay, now coming into the second order. Now coming into the second order reaction, the K value will be equal to liter mole inverse and the second inverse. Okay, so liter mole inverse and the second inverse, this is the unit that you can write for the second order reaction. Now, by keeping this in mind, can you go and answer the first part of the question? The K value is given as 3 into 10 to the power minus 4 second inverse. So what is the order of the reaction? What is the order of the reaction? Okay, what's the order of the reaction? Definitely it is the first order reaction. Very good. Definitely it's a first order reaction. Very good, guys. Now let's get into the second part. Write the unit of rate constant for a zero order reaction, which we have already written right over here. Okay, so units plays a really important role. So make sure that you learn the units of the key. Getting into the next question. For a reaction, reactant is converting into the products. Half-life is observed to be independent of the initial concentration of the reactants. What is the order of the reaction? Can you just let me know what is the order of the reaction? Okay, go ahead, go ahead. Quick, we don't have enough time. As I already told you, I don't want this one-way talking right over here. I want an interactive session. If you guys watching me over there, so make sure that you actively participate in the live session so that it will be useful for you for the exam, right? So just learn with me with the questions, okay? So how do you write the T half? Definitely, the T half for the zero order reaction. For the zero order reaction, how do you write? How do you write the rate expression for the zero order reaction, guys? Just let me know. Definitely it's the initial concentration. If you just write R naught over there, R naught indicates the initial concentration of the reaction. Okay, initial concentration. Okay, now divided by 2 into that's a rate constant. So this is how exactly you will be writing the T half of a zero order reaction. Now how do you write the T half for the first order reaction? How do you write the T half for the first order reaction? Just let me know. Exactly, that's equal to 0.693 divided by K. Okay, so that's how you will be writing the first order reaction, T half. Now how do you write for the second order reaction? How do you gonna write the T half for the second order reaction? Quick, let me quick. The second order reaction, that will be, you don't have to study that in the revision like in the chapter, but still you should have an idea for the JEE, and the students who is preparing for the JEE NEET must know what is the T half for the second order reaction. That is nothing but, so that's equal to T half for the second order reaction. This is for the second order, okay? This is for the second order. That's exactly equal to 1 divided by K into concentration, the initial concentration to be specific. Now, by looking into these equations, can you just let me know who is independent on the initial concentration of the reactants? Among these three, who is independent of the initial concentration? Looking into the zero order, definitely there is an initial concentration. Coming into the second order, definitely you can find an initial concentration over there. But in the first order reaction, can you find, sorry, I'm using an eraser. Alright, can you find a initial concentration over there? No. So the T half, which is independent of the initial concentration, is for the first order reaction. So the first order reaction is the right answer. Okay, so just write down it's the first order reaction and explain why. Okay, so why is it independent on the initial concentration? Because T half equation is 0.693 divided by K. I hope you know to derive all this equation. If you request on the other live, we can go ahead with the derivation of all these kind of equations, and also we can go ahead with the graphs if you just request for that. Okay, so if you know everything, it will be really fine. If you doesn't know how to derive the equation or how to draw the graph for this, definitely you can give a request, definitely we will do it. Okay, so we are here for you, right? So as per your request, definitely we will do it. Okay, now who's that? Big fan of you, ma'am. Thank you so much. 9 plus 9K followers. Who is that? Alright, I love chemistry. Definitely, everyone should love chemistry. Chemistry is the most important part in our life, right? Do you think we can live without chemistry? No, the oxygen that we are breathing in is chemistry, right? So without chemistry, you cannot live, guys. So definitely you should love. So those who are not loving chemistry, you should start loving chemistry from today onwards, okay? Because chemistry is an important matter in our life, okay? So make sure that you love chemistry, okay? Not only the other subjects. Now, I almost forgot the second part of the question. The reaction of the second order with respect to a reactant. Alright, this is an important question. I'm going to erase this, okay? Okay, let's read it together. The reaction is of second order with respect to a reactant. Definitely we have a reactant which is getting converted into the product. Where's my half of the P? Okay, here we go. So reactant is converting into the product. Now how do you write the rate expression? Rate law expression to be specific. Rate law expression can be written as K into concentration of the reactants. And they have clearly mentioned in the question that it is the second order with the respect to the reactant. What do you mean by the order of the reaction? It's just the sum of the powers, right? Now coming into the order of the reactant, it is second order, that means the power is 2. Okay, got the idea? So this is the first step to get into the answer. Okay, if you know this, the rest of the question is really simple. Okay, now let's go ahead with the rest of the question. How will the rate of the reaction be affected if the concentration of these reactant is? The first one double, second one is reduced to half. We'll do it. Now before that, I don't have much space, so I'm gonna just erase this. Okay. And, oh, I'm not able to erase that. Fine, we'll go. Okay, so rate is equal to K into R to the power 2. Now, if the concentration of R is doubled, let's go ahead with the first one. If the concentration of R is doubled, we can write concentration of R is equal to 2R. That's the first condition that we have to apply. The concentration of R is just doubled. Okay. Now let's substitute this in the rate law expression so that we can write it as that's equal to K in concentration of 2R to the power 2. Correct? What's 2 squared? No, the age doesn't matter for this. You are not supposed it is not like you should be in the 12th grade to answer this. Everyone must be knowing what is 2 square, right? Tell me what is 2 square? You're not supposed to be like in the 12th grade to know what is 2 square. 2 square is 4, right? So we can write as 4K concentration of R to the power 2. What do you mean by this particular thing? That means rate of the reaction is increased 4 times, right? Rate of the reaction is increased by 4 times, okay? So they're asking like what will be the rate of the reaction? Okay, it will be increased 4 times. You have to add on that sentence as well, okay? So the rate of the reaction will be increased by 4 times, okay? We'll go ahead to the second one. What happens to the second one? Alright, when we reduce the reactant into half, okay? So concentration of the reactant becomes half. That is, we'll be writing a concentration of R divided by 2. That will be fine, right? Okay, without writing 1 by 2, we can directly write R divided by 2. Okay, so we are reducing into half. Now let's substitute in the rate law expression, that is, rate is equal to K into concentration of R, that's by 2 to the power 2. So we can write it as 1 divided by 4 into K into concentration power 2. So I can say that the rate of the reaction is reduced 1 by 4 times, right? So the rate of the reaction is reduced into 1 by 4. Okay, so that's how you will be answering these type of questions. Do anyone have any doubts? Yeah, go ahead if you have any doubts. Miss too much concentration. Definitely. The chapter is all about the concentration, right? So definitely we have to learn about the concentration of the reactant. Alright, rate becomes 1 by 4. Okay, who's that, Chaku? Very good, very good. You're right, you are on the right track. I don't know who you are, but still you are doing a good job. Okay, now let's get into the next question. A reaction is of first order in reactant A and second order in reactant B. That means we have two reactants right over here, that is A and the B, which is getting converted to the product. We don't have to care about the products. Who cares about the product, right? It's all about the reactants. Okay, well, right, we have the A and the B. When they combine together, definitely they will be giving some products. Okay. Now, what are they asking for it? We did the similar kind of question in the previous one, right? So, try solving it by yourself. I'll do it by myself and you guys have to do it on the other end, okay? Now, coming into the first one, the concentration of B alone is increased to 3 times. To write this, you should know what is the rate law expression for this particular reaction, okay? So, let's write down the rate law expression first. That is, rate is equal to K into concentration of A into concentration of B. So, what is the order of A and order of B? It's given in the question, right? It's the first order reactant. The first order with respect to the reactant A, it's first order. Since it's 1, I'm not writing over there. Now, it is the second order with the reactant B. Second order, so it must be 2 at the top of the B. Okay, so if you know this much, everything is in your hand now. So, the first one, the concentration of B alone is increased 3 times. So, concentration of B will be equal to 3B now. Okay, so concentration of B is increased 3 times. Now, let's substitute that in the rate expression. So, rate will be equal to K into concentration of A into concentration of 3B. Okay, did we miss something? No, we have to write 3B over there. 3B to the power 2. What is 3 squared? What's 3 squared? Definitely it is 9. Everyone knows that. So, that's equal to 9K into concentration of A into concentration of B to the power 2. So, the rate of the reaction is increased 9 times. It's increased 9 times. How simple the chemistry is, right? Look at this. Now, coming into the second one. So, that is concentration of A and B. Both of them are double. So, concentration of A becomes 2A and the concentration of B becomes 2B. Shall we substitute in the equation? Of course we do. For that, we'll change the color of the pen. Okay. So, rate will be equal to K into concentration of A is just double. So, we'll be writing 2A into concentration of B is again double. So, we'll be writing 2B to the power 2. 2 square is 4. 4 2s are 8. So, that's equal to 8K concentration of A and concentration of B to the power 2. So, the rate of the reaction is increased 8 times. Okay. Is it easy, guys? Yes, of course it is. Okay. Now, if this is clear to you, we will move on to the next one. Oh my God, it's already 46. How come? The time went so fast. Okay, we have to finish the live within 15 minutes and we have a lot of questions remaining. Don't worry, we will cover up, okay? Now, we'll go with the next question. The rate constant for a reaction of 0 order is A, and now how long will it take for the initial concentration of A fall from this much to that? Okay. Now, it's clearly mentioned that it is a 0 order reaction. So, how do you write the rate law expression, the integrated rate law expression for the 0 order reaction? Do you remember it? How do you write the integrated? Very easy only. Okay. Alright. So, here we go. What was I talking about? The 0 order reaction, integrated rate law expression. How do you write the integrated rate law expression for that? So, integrated rate law expression can be written as K is equal to what? Let me know, quick. Rate law expression can be written as? There's no one in the class knowing this? Guys, let me know. I want an interactive session, you know that, right? Go ahead. No idea? Okay, we'll go. So, rate law expression K can be written as initial concentration minus, okay, hold on a second. Initial concentration minus the final concentration divided by T. Okay, so this is how we will be writing the integrated rate equation for the zero order reaction, and everything is given in the question itself, right? So in order to find T, you have to find the how long it will take. How long it will take indicates that how much time that you have to take, right? So you have to find the T. So T is equal to initial concentration minus final concentration divided by K. Now just a matter of substitution, right? How do we substitute it? What is the initial concentration? 0.1 into 0.075 divided by, what is the K? There we go, 0.0030. Okay, just find the answer and let me know in the comment section. Let me check how many of you are doing it actually. So solve the question and let me know. Okay, so I'm only able to say the Chaco in the comment section. There's no one other than Chaco, and Chaco is really doing a good job. May I know your name actually? Is it Chaco yourself? Alright, anyway, you're doing a good job in the comment box. But others, are you all asleep already? I'm getting 8.33 seconds. Are you sure about that? Definitely. Alright, so 8.33 seconds. Okay, so good job, you got the value. Okay, we'll move ahead. So this is how you'll be finding the answers. Okay, right. We'll go with the next question. What do you understand by the rate law and the rate constant of the reaction? Something you have already explained, right? We have explained what is the rate law and what is the rate constant of the reaction as well. If you didn't got the definition for that, here we go. Okay, so this is the definition for the rate law and the rate constant. Okay, just quickly take a screenshot of this and write that down later after the class. Okay, or just pause the video and write down. We'll move ahead. Okay, this is the equation. I hope you got it, and I'm going to change the slide in 3, 2 and 1. Here we go. Okay, coming into the second part of the question, identify the order of the reaction if the unit of its constant are. The units are given. Now just let me know what is the order of the reaction. If you have listened to the class very well, you should know what is the order of the reaction, because this is exactly what I have explained in the second question, I guess. Okay, so go ahead and let me know the order of the reaction. Okay, I'm waiting right over here. I'm waiting. All right, I'm waiting here. Okay, just let me know the answer. All right, Chaco is there to help me out, of course. All right, so the first one is your zero order reaction. The first one is your zero order reaction, and the second one is your second order reaction, not the first. Okay, it is the second order reaction. And what's the unit for the first order reaction? It's just the second inverse. Just the second inverse. Okay, very good. We'll go with the next question if you're done with this. Okay, the answer for the last one. Here we go. The thermal decomposition of HCO to H is a first order reaction with the rate constant this much at a certain temperature. Calculate how long will it take for the 3/4 of initial quantity of HCO to H is decomposed, and the log value is also given. So what else do you want? It's nothing. So you can solve it by yourself, right, if you know the equation. So it's clearly mentioned that it is the first order reaction. How do you write the integrated rate expression for the first order reaction? For the zero order reaction, we know that initial concentration minus final concentration divided by T will be giving you rate constant of the reaction. So in the first order reaction, how do you write? What was that? Was it my K? Yeah. So K is equal to, how do you write the equation first of all? So equation is nothing but, okay, so 2.303 divided by T log initial concentration divided by the final concentration. This R not right over here. All right, is it not clear? We'll go with this. Okay, So R naught indicates your initial concentration and this R indicates your final concentration. Okay. Now, are they given with the initial concentration of the reactants? No, they haven't. So let's take it as R naught itself. Now, they're asking you to find 3/4 of the initial concentration. Now, final concentration is the 3/4 of the initial concentration. Okay. So let the initial concentration be R naught. This is your initial concentration. Initial concentration. Now, how do you write the final concentration? It's really simple, okay? So, we know that it's 3/4 of the initial concentration. So, final concentration can be written as 3/4 of the initial concentration. Correct? It's 3/4 of the initial concentration. Okay, now let's take the change in the difference. Okay, they have reduced into this much, but when we take the change in the concentration, definitely you have to subtract this value from the initial concentration. So exactly, we are going to write it like concentration, which is initially present in the reactant, minus 3/4 of the initial concentration. That's how we'll be taking the difference, right? So initial concentration minus 3/4 of the initial concentration. Now, if we know this much, let's substitute in the equation. Let's substitute in the equation. Okay. So before that, we can simplify this, right? So initial concentration minus 3/4 of initial concentration can be written as initial concentration divided by 4. Just a simple mathematics, correct? Now, let's substitute K as equal to 2.303 divided by T log. What is the initial concentration? We'll be taking it as R naught divided by. What is the final concentration? It is R naught divided by 4. Okay, which we can write it as log 4. Now, where do I write? So, shall we get into the next page or shall I erase this? We'll erase the top one and we'll write. Okay, so I'm going to erase this. I hope you're writing along with me. Okay, so we'll write. What do we have to find, by the way? We have to find how long it will take. We have to find the time. So, time T is equal to 2.303. What is the K value? What is the K value they have given in the question? It is 2.4 into 10 to the power minus 3 log. What is the initial concentration? We'll be taking it as 4 and initial concentration we can cancel them and we can write 4 over there. And the log 4 value is already given in the question, matter of substitution. So T is equal to 2.303 divided by 2.4 into 10 to the power minus 3 into 4. Okay, can you just solve this and let me know? Solve this and let me know the answer in the comment section. Okay, go ahead. Find the answer and let me know in the comment section. I'm waiting for the answer, guys. I'm waiting for the answer. Yeah, log 4 value. You have to write it as 0.621. Okay. Go ahead. I'm looking into the comment box and there's no response at all. Okay, what's the answer that you got? Okay, go ahead. Let me know. Find the value. Find the value. All right, you are getting it as, where is my value? So you will be getting it as 577.5 seconds. Don't forget to write the units. Okay, units are really important. So we are finding the time. So represent it in seconds. Okay, seconds is the SI unit of time. So always remember to put the unit over there. Don't forget unit carries a mark. Okay, unit carries a mark. If you just forget to write the unit over there, definitely you're going to lose the marks. Half mark is for the unit. Okay, remember that. Now you will get the answer by using the integrator rate expression. We'll go ahead. Okay, all right. Now, rate constant K for the first order reaction has been found to be this much. Calculate its 3/4 of the life. It's same question, right? It's the same as the previous one. Okay, we are finding the 3/4 of the lifetime. And you can apply the same equation and the values is almost the same, right? So you can apply the same equation, same method, and you can go ahead with that. Okay, will you guys do it as a homework after the session? So you can write this down, write down the question and solve it, and let me know the answer in the next live session or just in this comment session itself. Okay, so I'll look after the answer after the live classes. Okay, so if you answer me, definitely I'll give you some gifts. Definitely, it's Children's Day, right? I'll give you a gift if you just let me know the answer. Okay, now we'll go with the next one. Okay, all right. A reaction is of the second order with respect to a reactant. How is the rate of the reaction affected if the concentration of the reactant is reduced to half? We have done a similar kind of question. Again, you can find the answer by yourself because we've done the similar kind of question. Why? Because I am adding the same kind of question because you should know these are the repeated questions, so that you have to focus on that question. Okay, so make sure that you focus on the questions like this because they are repeatedly asking this. Okay, now getting into the next important question. For a reaction A plus B gives B, the rate law is given by the rate expression. What is the order of the reaction? You know how to find the order of the reaction, right? So before getting into that, can you just let me know what is order of the reaction? What is order of the reaction? If you take the sum of the exponents of the concentration of the reactant, definitely you're going to get the order of the reaction. So for this question, how do you write the order? So we know that rate expression is equal to Ka to the power 1/2 in the concentration of B to the power 2. So these are the exponents about the concentration of the reactants. Now let's just add them up. So order is equal to 1/2 plus 2. So 1 plus, it will be 4 and 5. So 5 divided by 2. So that will be answer. That will be equal to 2.5. So 2.5 is the right answer. Okay. Now getting into the second one. The first order reaction is found to have the rate constant as thus. Find the half-life of the reaction. So you might be already knowing how to find the half-life of the reaction, right? And they have given that it is the first order reaction. Shall I erase this? Okay, so how do you find the order of the first order reaction? So T half will be equal to, it's a first order reaction. It's a first order reaction. So how do you write the T half of the first order reaction? That will be equal to 0. I have explained this, right? 6.693 divided by K. Now it's independent on the concentration, initial concentration. So let's substitute it. 0.693. Do you know how the value comes? 0.693. For that, just you have to do the derivation. Okay, then you will get to know that. If you're not able to do the derivation, just let me know. I can help you with that. Okay. Now divide by K. What is the K value? It is 5.5 into 10 to the power minus 14. Okay, so if you do this, definitely you're going to get the T half of the reaction. And after doing the calculation, don't forget to put the unit. It is in seconds. Okay, second as a unit. So make sure that you do the numericals. Okay. Hello Babu. Hello. I saw your comments. Okay. Yeah. All right. Now getting into the next part. Write two difference between the order of the reaction and molecularity of the reaction. You have to find the order and the molecularity of the reaction. Okay. After doing this question, we will wind up this session and we'll continue the rest of the question. Definitely we'll be having more questions in this chapter. We'll continue in the other session. Okay. So, but we have to complete this first. Okay. We'll complete this and we will move. Okay. Now coming into the question, write two difference between order of the reaction and molecularity of the reaction. You might be thinking they're only asking for the two difference and why do we have three columns over there? I'll give the three difference. Study whatever you want. Okay. So I'm giving you the option. So what is the order of the reaction? So first difference, you can write down the definition of the order and the molecularity. Okay. Coming into the order of the reaction, it is the sum of powers of the concentration of the reactants in a rate law expression. In a rate law expression, okay, and we know that order of the reaction is an experimental value, okay. If you have a balanced chemical reaction, definitely you cannot write the order of the reaction. For that, you should know the experimentally determined values that we have written as x and y, right? The experimentally written value, they can be equal to the stoichiometric coefficient, they cannot be, maybe they are not equal to the stoichiometric coefficient as well. For that, first thing that you need is the rate law expression, and can be only determined experimentally. So it's an experimental, hold on a second, experimental value, okay. It can be determined only by experimental values, okay. And the next thing that you can write it as, the order of the reaction can be a whole number, can be a whole number, can be 0, and can be fractions as well. Okay, order of the reaction can be fractions, it can be 0, it can be whole number, as I wish for. Okay, but coming into the molecularity, what do you mean by molecularity? First of all, molecularity is nothing but they are the number of moles of reactants, number of moles of reactants. Okay, how many moles of reactants are reacting in a particular chemical reaction? So total number of reactants will be giving you molecularity of the reaction, and the molecularity can be defined if we have a well balanced chemical equation, because if you add those stoichiometric coefficients, definitely you're going to get the molecularity of the reaction. And remember, it's about the reactants. Okay, so molecularity of the reaction, it's just a theoretical concept. Okay, so I'm rushing to wind up, that's why my handwriting is getting even worse. Okay, don't mind. So it's just a theoretical concept, and it cannot be fractional, it cannot be 0, it can be a whole number. Okay, it can be a whole number. Do you think if we have 0 reactants, will the reaction proceed? No, right? So the molecularity cannot be 0, cannot be fractional, and cannot be 0 as well. Okay, so it can be only a whole number, remember that. Okay, so this is how you will be differentiating the order of the reaction and molecularity of the reaction. Okay, so if you know this much, can you all give me a thumbs up so that we can wind up the session? So can you just give me a thumbs up so that we'll wind up, and we will meet in the next session so that you can clear the doubts on that session as well. We'll continue with the kinetics. We have some questions remaining, right? All right. So of course I'm getting a lot of comments in the comment session. Definitely, thank you so much for your love towards me, and thank you so much for being active in the comment session. Okay, so I'm winding up, and I will see you in the next session with more questions. So stay tuned with the Go Score, and I'll meet you.